Okay. And then what are you going to observe? Okay. All right. Cool. Good start. So what are you guys doing? Who's in your group? 53. Okay. So what are you going to burn? Okay. Is there a time limit? No? So you're going to let people die? Alright, cool. That's fine. Fair enough. So 5 people? Okay.
So we are doing our best and
Okay. And what are you going to observe? Okay. Alright. What are you guys up to? Do you have a group? Fire on bed. Okay. Okay.
And the occupant is sleeping. At T equals to 100 seconds, the fire goes in the whole bedroom. Consuming oxygen, the heat breaks the window. First, allowing place their team to fire suddenly flares up.
Okay.
At T equals to 120 seconds, the occupant wake up and open the bedroom door to escape. This black smoke rushes from the bedroom into the team. At T equals to 100 seconds, the occupant open the main apartment door to escape, creating a flow path from bedroom window to main hall.
Okay. Alright. It's too complex, but simplify it, maybe, if it's possible. Okay. What's happening with you guys? You have a group? So group is formed, but we don't. So they're gone? 3 people? Okay. So that's this is your team. So what's the plan? Mm-hmm. Okay. And that's it? Okay. And what are you going to observe? Okay. What's happening with you guys? 2 groups. Okay. So what is your group? Okay, so what is the scenario?
Will be light fire in the beginning, sofa, maybe 4 TV or something, and then there will be another person sleeping in the bedroom. So when the smoke reaches, then
Alright, cool. That's fine. So, yesterday I gave you one more task, which was building the apartment. Right? So how many of you actually built the apartment? You built the apartment? Wow. Okay, anybody else? So this group did it. Anyone else? No? That's good, okay. So you built a frame. That's good, good. What about you guys? What about you guys? Okay, alright. So why don't you guys show it to everyone? Let me see. The apartment, they have a lot of work to do now, today. Otherwise, what are you going to present tomorrow morning? And building the apartment is the most, or building the geometry is the most difficult task. Okay? Not actually burning. Anyways. So today, we are going to burn stuff. Okay? Burning stuff is actually fun. When you do the burn experiments, it's fun if you do it with safety. Here, we are going to burn in the simulation. Okay. So in your desktop, create a folder called couch. Couch. Create a folder called couch. COUCH. Then copy the couch.fds from your examples. Do you know where the examples are?
Yes, sir.
Go to the examples of FDS and copy the couch.fds file and put it in your desktop folder. Yeah. Go to file models. There are examples. Yeah, under the examples, I think there's a files folder. Under that, there's a couch.fds. Yeah. Not couch. Alright, open that with the text file, like text editor. You will see a code like this, okay? And due to lack of time, I'm just going to go through the code and explain you how we actually burn stuff, okay? Alright. Can you guys see read it from the back pages? Yeah? Yes. Okay, alright. So, help me out. What is the first line doing? It is right? Okay. What is the next line doing? Right. So, if you compare this with your yesterday's job file, okay? In the yesterday's job, you had basically mesh, right? XB is equal to 6 coordinates, right? And IJK, the mesh resolution, right? Here, this is another way of doing the mesh, okay? So, in here, you have a domain which is basically 5 by 5 into 2.4. So 5 by 5, 2.4. Okay? So you can actually mesh the whole domain. Okay? No issues. This is just another way of doing the mesh. So melt ID mesh is basically what it is doing. It is making 4 equal parts of your computational domain. Okay? So, and then basically it's doing the meshing the first 2.5 in x direction to first 2.5 in y direction. There is no dz, so basically meshing the whole way up to 2.4. Okay? So it will do that mesh and then it will go to the next half of the computational domain. Okay? Then the next half of the computational domain. So this command is basically saying replicate that mesh in x direction once and y direction once, and then it will completely mesh your computational domain. Yeah? So basically you have your domain, you break it into 4 parts, and then you are telling FDS to replicate that whatever mesh that you are doing in for one small part, replicate that in all 4 parts. Okay? So that's what it is. Okay? You don't have to do this way. You can do it in the other. Okay? The way we did it yesterday. Cool? Okay. Then what's this line doing? It is specifying how long is the simulation, right? I'm sorry? It is telling basically that I want to record 3000 frames in 600 seconds. That means what is the frame rate? 600 by 3000, 1 by 5, that means 0.2 second. For every 0.2 second, I need a frame. Okay? In this line, what is this dt device, dt device is equal to 5 or dt HRR is equal to 5? What is it? I'm sorry? Okay, what is it telling? What is it for? What is the purpose of it? It is actually telling FDS that record the value of heat release rate and whatever temperature or whatever you want to record every 5 seconds. Yeah, alright. So you are recording heat release rate every 5 seconds, and I think device is recording, I guess, temperature at the end. Yeah, so it will record temperature also every 5 seconds. Yeah, okay. Then this is so here. In the previous example, the example that we did in the last lecture, okay, we used a fuel which is propane, and that was predefined in FDS. Okay, here we are going to burn a couch, right? So when the solid burns, how does solid burn? How does solid burn? What is the next? What burns actually? Vapors, right? So you have a solid which transforms into gas vapors, and those gas vapors actually burn, right? So those gas vapors are actually fuel for the fire, right? And here we are basically telling FDS that the solid couch is going to transform into a fuel which is equal to polyurethane, and this is the formula for your polyurethane. So polyurethane is not defined in FDS, okay? So then FDS wants to know what is the composition of it. And this formula specifies what is the composition of it. Now here you have carbon, hydrogen, nitrogen, and this thing is O, means oxygen. Okay? So it's saying basically my fuel has 6.3 carbon atoms, 7.1 hydrogen atoms, 1 nitrogen, and 2 oxygen atoms. Okay? Now you can change those numbers based on whatever fuel that you have. Alright? But if you are using polyurethane, which is not defined in FDS, and if you don't specify the formula, you will get an error. Okay? Because it doesn't recognize what your fuel is. Alright? Then you are specifying the properties of the fuel. How much heat will be released? How much soot or the smoke will be released upon its burn. Okay? Again, these are your properties of the fuel, which you can either find from the SFP book, Society of Fire Protection Engineers, or from your own database. Okay? Alright. So the way you assign or you burn the objects is you define the material, okay, and then you define the properties of the material. Alright? So for a couch, we are going to have 2 layers of couch. A couch will have a fabric, and underneath it we will have foam. Okay? And using this block, we are going to define what are the properties of it. Alright? So this is saying a material is fabric, and here you can write a description. Okay? What is the specific heat, conductivity, density of it? Okay? Those are self-explanatory parameters, so I'm not going to talk about that. There is NU space is equal to 1. So it is telling FDS that the 1 kg of fabric will generate equivalent 1 kg of fuel vapors. Okay? It doesn't have to be 1. You can say 0.5, whatever. Okay? For the just a demo purpose, it is 1. Then, if fabric burns, it is going to transform into fuel, polyurethane. And then you define the properties of the polyurethane. Okay? Then, at what temperature it will start burning? Reference temperature. How much heat is required to start that reaction of burning? And once it starts burning, how much heat is going to be released? Those are all the properties of the fabric. Are you with me? Is there any property that is not clear? Okay. Similarly, for the foam, again, you define, okay, this is a foam. You are going to refer that somewhere else. Okay. Then what is the specific heat, conductivity, density? Again, NU spec is equal to 1. And what does that mean? If NU spec is equal to 1, what does that mean?
Per kg of solid, 1 generated per unit.
So 1 kg of foam will generate 1 kg of polyurethane, fuel vapors, right? Okay. Then, what is your fuel, right? What is the reference temperature, right? And what is the heat of reaction and heat of combustion? Are you with me? Yes? Alright. Sorry? And 800 is the heat of reaction, not a temperature. 280 is the reference temperature at which it will start burning. Okay? Alright. Now, for walls, if you don't specify what is the material of the wall, yes.
What is the meaning of new spec?
Okay, what is the meaning of new spec?
Fuel vapors generated per unit of.
Let him hear that. Be loud.
Fuel vapors generated per unit of the material.
Did you get it? Okay. Alright. Material ID, gypsum plaster. So, if you have a wall, if you don't define what is the material of the wall, it will just take it as a solid inert wall. Okay? But if you want to specify what is the type of wall, so in the US, everything is, you have gypsum, a thin sheet of gypsum plaster, then you have a hollow, and then you have another gypsum. So if you are having fun in your apartment, the neighbor can hear it. Alright? But anyways, and also there is actually a fire barrier in between, which I so you have, so that the fire does not spread. But I don't know if you follow the news, the fire actually spreads, no matter what. Anyways, so you have, this is the material of the wall. Yeah? Then, so the way you define or you specify the material of the object is, you have a volume, right? And then you define what is the material of the surfaces of the volume. Yeah? So you have a sofa, right? In the sofa, you are saying there is, on top of every surface, there is a fabric. Yeah? So that is, you are saying surf ID is equal to upholstery. You will say it down. Okay? So maybe let me show you. So this is, so the way in this problem they configure the sofa is basically, you have a seat, then you have arms, okay? Then you have one back. Alright? So that's why you have 4 surfaces, and underneath the sofa, I think they have a small drop, okay, which is not going to burn. Cool? So those 2 arms, seat and the back, will have upholstery as the material. Okay? So now FDS knows that all these volumes have their surfaces are upholstered. Okay? What is the property of the upholstery? It's basically saying that that surface has two layers, fabric and a foam. What is the density? What is the thickness of each layer? The thickness of each layer is 0.005 meters and 0.1 meters. Are you with me? Are you following me? Yeah? Okay. And now you have defined what is the material of the surface, right? But what are the properties of the surface? What are the properties of those materials? Which we define here. Okay? So you define the surface, you define what constitutes the surface, right? And then you define the properties of that material. Okay? Are you with me? So it's kind of a three-step process. Yeah? Cool? Alright. And then you define what is actually purpose of this. Is it clear? Are you on the same page? Okay. Similarly, for the wall, you are saying if the surface is a wall, its material is gypsum plaster, and then we define what are the properties of the gypsum plaster. Alright? So now here, using this, what are these commands doing? What is the ampersand ops? What does it do? It creates the object, right? So then these are basically creating the arms and the seat and the back of the couch. Okay? And then surf ID is equal to upholster. So we are defining what is the material of those surfaces. Inside those materials, so you define the surfaces. So you have a 3D object. You define the surfaces. Inside, what is it? Okay? You can say by manipulating the thickness, everything is 100% of the object is actually fabric and foam. But now, if not, you can say the backing is void. So below the fabric and foam, there is nothing. Okay? So don't burn anything. Okay? If you want like a solid couch, you can design your own. Yeah? Alright. And then the surface is not going to be 100%. So what is the density of that surface? What is the density of your material? So that is your bulk density. What are these three lines doing? Anyone? What are the next three lines doing? It's igniting. It's creating a fire. Okay? So the way it is done in this example, particular example, is that imagining that somebody had a cigarette on the couch. Okay? And so the way they design the cigarette is by creating an igniter particle. I'm sorry, I should keep it on the speaker, but the rules don't apply to the professors, right? No. Alright, so the igniter particles, so here again we are defining what is the surface of that particle, and then in the next line you are going to define what are the properties. Okay, so you are basically saying the temperature of every surface of that particles or the object is 1000 degrees. Okay, now here we will see the geometry of the cylinder and the length and the radius. So the geometry is equal to cylinder. What that means is the cigarette is a cylinder, right? So it's kind of trying to replicate that it's a cylindrical burn, okay? Because you are going to basically place the igniter using like a rectangular coordinates, Okay, so it will try to mimic a cylindrical surface. Okay, are you with me? Okay. And then the important parameter here is n particles per cell. So now you have an igniter. Because of the meshing, it is going to generate, I don't know, 10 cells in that object. Okay, and it is basically saying that there are n particles per cell. So there is one particle in that object. So there will be 10 particles which will have these properties. Yeah. So when you do simulations, in your simulation, or let's say if you are investigating a fire, and if you know that somebody was actually smoking inside the apartment, and if you want to replicate that, right? You don't have to think much. You just go to the couch.fds file and take your burn. Okay? And then if you know specifications of that cigarette, you know how much it is going to release and everything, then you can modify all these properties. Okay? But otherwise, if you just want to replicate a cigarette, then you go to the couch.fds, copy these 3 lines, put it in your file. Okay? Are you with me? What you need to modify is the coordinates. Okay? Whether you are smoking on the bed or the couch or wherever your bed is, you need to position this there. Are you with me?
Yeah.
Cool. And then, when it is equal to this line, so what is it doing? What is that line doing? It's like you have a room, right? And then they basically said one surface of that room or one side of that room is completely open. Okay? So that the smoke and the heat can go out of that room. Okay? So that's why you have surf ID is equal to open. Are you with me? Okay. And then B and F, so that's basically boundary values. Okay? So they are measuring what is the heat flux on all the walls. Okay? On every surface, what is the radiative heat flux, convective flux, negative flux, and so on. Yeah? Are you with me? Questions? Alright. What are these 2 lines doing? So is it a sensor or what?
Temperature control.
What is it?
Slice.
It's a slice, right? So you are going to get a temperature distribution across one plane. Yeah, are you with me? Same with the heat release rate. Cool? Alright. So now, I'm sorry.
The temperature will be found out. But what is the PV?
Sure. So PVX is equal to 2.5. Can anyone explain what is that? What does that mean? Did you hear that? Okay, tell him again.
At x equal to 2.5, there is a slice.
Yeah? Okay. What else? So by default, it is going to take +1. Yeah? So it's going to go on that. Okay? So, do you understand each and every line in this code? Any questions? Alright, run the code. Sorry? No, yeah, if you don't specify, you just start. Yeah. So, if you see, the fire started. Okay? Sorry? Okay. So the fire started, and you can see that the sofa is slowly disintegrating. Yeah? Now let's say if you want to see the smoke. How do you see the smoke here? And if you want to see the temperatures, you can see it in the slides. Yeah? If you want to see the boundary values, you go to boundary and then you can see all the radiative flux or convective heat flux and all. Okay? So now you can see how much actually heat flux is on all the surfaces, all the walls and everything. Alright? Cool. Let me try this. Alright. So that's how you basically see all the results. Are you with me? Questions? Cool. So now, I'm going to simplify your exercise. Okay? In your exercise, remember you had a lot of furniture. Okay? In that furniture, so you have wooden table, right? I think 5 tables, bed, and couch and stuff. Okay? Since you are presenting tomorrow, what I want you to do is take the same couch. Okay? And if you want a fire in living room, put the couch in the living room. If you want the fire in the bedroom, put the fire in the bedroom. Put the couch in the bedroom and take the same burner. Okay? So imagine that there's a couch in the bedroom or the living room, somebody was smoking and then it started the fire. Okay? And forget about all the other furniture. It's just a repetitive process. So let's not waste time in that. Are you with me? Alright. So people who have geometry should start copying, place the sofa in that. Okay? Are you with me? Do you know what to do? So have fun. Okay? And if you struggle with it, I'm here. Okay? And if you did not get the geometry and if you're struggling with some aspect, try to take the help from the people who actually built it. Okay? I think this group built it completely. Right? Show me. Yeah, amazing. Good. Okay. The only problem with that is you don't have a computational domain outside. Right? So if the smoke gets out, you don't know where it's going. Okay? So do that. Okay? So start copy pasting the code of sofa, put it in your files. And that's how actually you simulate MDS. So you build a geometry, okay? And then you go to your examples and then copy, I don't know, sofa, put it in your file. Copy cigarette, put it in your file. Copy table, put it in your file. And that's all. Okay? What you need to play with is the coordinates. When you copy paste the sofa, you will figure it out. Okay? And that is going to be the real fun. So, start. So, do you receive the file? So if you copy that file, so create a folder on your desktop. And if you copy that file and run the simulation, you will see a geometry like this. Are we on the same page? What do you see? Oh, you have, I also placed the couch for you. Inside. Okay, alright. So now you need to move the couch to wherever you want to start the fire. So, people who started the fire in the bedroom, move the couch to the bedroom. Okay? And then, so now you have basically your entire geometry with the fuel. Maybe what we can do is, you have one couch in the living room, one couch in the bedroom. Okay? And then you can burn any of that. Cool? So, to burn the couch, what do you need to do? Alright, I'm only here for the next 15 minutes. So, let me just go through the code. Alright? So, people who created the geometry, they will understand basically this is creating the computational domain with the open boundaries. Yeah? Cool? Then, these are your walls. Yeah? So 4 walls and a ceiling. Okay? These are the partition walls. So there is one partition in the middle, right? There is one partition with the public hallway. Right? So those are the partition walls. And that will create your geometry. Are you with me? Okay. Then, once you create the geometry, what do we need to do? We need to create doors. Right? So, we also have, I also created the doors and the windows. Okay? You should have that in your code. Okay? And then, based on the scenario that I described to you yesterday on my slides, I'm opening these doors and the windows at certain instant. Okay? So based on whatever scenario you describe me, you need to open them at certain instant. Maybe for if you want to add the complexity, maybe you can say I want to bring the window at certain temperature, I don't know, 100, which is easy to reach. Okay? And then the next part is burning the couch. Okay? So instead of writing the code from scratch, what I did is I copied the sofa from that couch.fds and pasted it here. Okay? So if you remember, these are the exact 2 lines from the couch.fds. Yeah? Then that couch also had, we had fabric and foam, right? So I basically copy pasted the material properties from the couch.fds, pasted it here. Yeah? Then I'm defining the surface of the couch, which is also copied from the couch.fds. Yeah? What is the next part? Building the couch, building the geometry of the couch, right? So I actually copy pasted all those lines, the 5 lines of the arms, the sleeve, and the back from that file. But then when I did that, it was in the middle of the wall. Okay? So then I had to play with the coordinates so that the couch goes into one corner. Okay? So now what we need to do is you can take the same couch and maybe create another couch in the bedroom. My couch is the living room, right? You need to put it in the bedroom also. Are you with me? Especially for the people who are creating the fire in the bedroom. Okay? What's missing here? Fire, the igniter, right? The cigarette. So again, I copy pasted those 3 lines of the cigarette here. Okay? And then it will start the fire. Are you with me? Cool? Now, in this entire file, you have basically complete answer. Now you just need to create a replica of the couch, put it in the bedroom, and manage your events. Now you need to open the doors and the windows at certain instant. Okay? So you are going to manipulate these numbers based on your scenario. Are you with me? Right? What else is required in this file? I mean, that again, you will open the stairwell door at certain instant. Okay. What's missing? The sensors, right? How do we measure the temperatures and everything, right? So, at the bottom of the file, you will also see that. Okay? So these are, so the requirement was that place the sensors in the center of each room, right? So there are 3 sensors: living room, bedroom, and public hallway. Okay? Then I am also measuring the velocity of the combustion products that are coming out of the doors, right? So there are 3 sensors at the center of the door. Okay? Then you have the slice files. So there is a slice from, so there is, these are deep slices. That means there is a slice at the bottom, there is a slice in the middle, there is a slice in the, at the top. what should you expect? What should you expect in those three slices? So where is the temperature higher? The top one will be hotter, then the middle one, and then the bottom. Okay? And I also wanted to see what is the slice temperatures across the door plates, right? So okay, where is it? Okay, so here, so this is Z, there should be X or Y. Yeah, okay. So here we are also plotting the temperature and the velocity distribution across the plane that is going through the door. Okay? Alright, so everything is there. Now we just need to create your scenarios. Okay? We need to customize this for your scenario. That's all. Do you understand each and every line in that code? Because tomorrow I'm going to ask you. At least you should know that much. And tomorrow, I also want you to plot the temperature and the velocity curves. Okay? I want to see if you finish the simulation, right? And what is the temperature distribution? What happens when you open the door, when you open the windows, right? What happens to the temperature at that instant? If a firefighter is making an entry, how much temperature he is going to face? Okay? Are you with me? So you need to go to the CSV files and start plotting those temperature curves, velocity curves, and everything. Okay? Are you with me? Alright, any questions? Yeah. It is done, right? This file is with you, right? Yeah, that's what you need.